Okay. Optimal page replacement is the replacement technique where the pages are replaced depending on the page which will not be used for long time in future. Okay, so the page which is not used for a long time in future, such a page will be selected as the victim page for page replacement in optimal page replacement technique. Okay, so it is the name says it is optimal, means it is the best page replacement technique. Okay, fine, I'll tell about the problems in page optimal, we'll see later. Okay, now for this particular reference string, initially the frames are empty. Okay, so there are 3 frames as per the question. Suppose there are 3 frames and 3 frames are empty. Okay, now first page number 7 is required. Page number 7 is not there in the primary memory. Primary memory frames are empty. Okay, so it is a page fault. So page fault 1 here, and 7 is brought from secondary memory to primary memory. Okay, this is primary memory. Fine, consisting of 3 frames. Next, page 0 is not there. Page 0 is brought to memory. Again, this is page fault 2. Next, page this is page 1 is required. Page 1 is not present in memory. Okay, this is page fault 3, and page 1 is brought to the memory. Okay, now page 2 is required. I have to replace one of the pages with the page 2. Okay, page 2 is has to be stored. Okay, one of the frames must be selected here as the victim frame. So out of this, which frame has to be selected as victim page? See the future strings, observe the future strings. Okay, optimal page replacement technique replaces the page which is not used for a long time in future. Okay, so when you observe, out of this, that is page 7 is there, 0 and 1. So in the near future, page 0 is used. Okay, I have not replaced that. And then page 7 or 1 is there, 1 is used here. Okay, so 1 also is retained. Okay, 0 and 1 is retained. Page which is not used for a long time, that particular page is replaced by page 2. So 2 comes here. Fine. Next, page 0 is required. Page 0 is already there in primary memory. Okay. All these are the copies of same memory. Same memory I am showing again and again whenever there is page replacement. A new page is brought. Okay, it is the same memory. So it is same thing as retained. Page 0 is already there. Okay, it is already there. Next, page 3 is required. I want page 3 to be brought to the main memory. So observe the strings which is required in the next future. Okay, so page 3, I have to replace, select any one of those frames. Okay. So 0 is present, 0 is present, and next 2 or 1, which is next immediately required. 2 is required. Okay, so retain 2, and 1 is there. 1 is also required in the future. Okay, later on, but in the near future, I want 0. I want to retain 0, and I want to retain 2. Okay, hence page 1 will be replaced by 3. Okay, next page 0 is required. 0 is already there. It is not a page fault. Next, page 4 is required. Page 4 is not present in the primary memory. The pages available are page 2, 0 and 3. Okay, page 4 is not there. Page 2 is immediately required. You can observe here page 2 is immediately required. So retain it. And then page 3 also is immediately required. So retain it. Okay. Page 0 comes next after page 2 and after page 3 0 is coming. So 0 is used later, hence page 0 is replaced by 4. Okay. So in this situation, page 0 was required, 0 is already there, no page fault. Okay, page is already there. Next, page 3 is required. Page 3 is not available in this primary memory. Observe the strings which are required in future. 0 is required, so retain 0. Next, 2 is required, so retain 2. Okay, 1 is required later on. First, this 0 and 2 are required. Okay, so replace 1 by 3. Fine. Here also page 0 is already there, so just leave it. Next, page 4, 2 and 3, which is page 4 is required now. Page 4 is a page fault. It is not available in this primary memory now. Okay. Next, we should search for the frame, victim frame. Okay. So page 2 is required next. Page 3 is next required. Hence 0 is replaced by 4. Okay. Page 2 is already there. No page fault. 3, it's there. No page fault. 0 is required now. It is a page fault. Okay. Which frame to be replaced? So 3 is immediately required. Next 2 is required. Hence page 4 is replaced by 0. Okay. Next 3, there is page. 2, there is page. No page fault. 1 is a page fault. Page 1 is not available in primary memory. It is a page fault. Okay. By observing the future string, 2 is the string. I need it. Okay. So block. And then 0 and 3. Out of this 0 and 3, there is a tie because there is no future strings available in the question. Okay. Whenever there is no future strings available, so out of this, whenever there is a tie, 0 or 3, observe the string which has come first. Observe the page which has come first. So which has come first, 0 or 3? 0 has come here, and page 3 was available from the stage itself. Okay, so 3 will be replaced by 1. Fine. So this is optimal page replacement technique. We can observe that out of any of the page replacement techniques, optimal page replacement gives the best result. Okay, gives the maximum means less number of page faults. Okay, here you can see the number of page faults. How do you find the number of page faults? By counting the number of towers what you have drawn here. Okay, 4, 5, 6, 7, 8. So number of page faults is 8. Okay, so but the problem with this page replacement technique is it cannot be implemented. Why it cannot be implemented? Because the operating system cannot know, the system does not know what is the instruction which is requested by the processor next. Okay, the system cannot predict the future strings. System cannot predict the future strings. Fine, but a string given, I can find what is the page fault. So optimal page replacement technique is used as a standard for measurement. Okay, for measuring which is the best replacement algorithms. Out of the algorithms which can be implemented, optimal page replacement is used for measuring the best which can be implemented. This is used as a standard. Okay, for measuring, that's all. Fine. So this is optimal page replacement. We'll just see for this particular string what is the optimal number of page faults. So you can, it is not animated, it is 7 as already shown here. Okay, however 3 frames are taken, so it is the empty frames. Okay, so page fault, page number 1 is required, it is not available. So it is a page fault. All of you can do it in your book now itself, okay, and then compare with what I solved. Okay, so page 2 is required. There is a page fault. Page 2 is not available in primary memory, and hence page 2 is copied. Okay, next page 3 is required. Page 3 is not available in the primary memory. There is a page fault. Page 3 is copied. Next page 4 is required. It is a page fault again. It is not there in primary memory. See the strings which you want in the future. You are doing optimal page replacement. See the future strings. Okay, 1 is required, 2 is also required. Hence, replace page 3 with page 4. Okay, next page 1, that it is not a page fault. It is page is already there. Okay, page 2 is also already there. Next page 5 is required. It is not. Page 5 is a page fault. It is not available in primary memory. Again, see the future strings. Okay, so 1 is immediately required, block it. 2 is immediately required, block it. 4 is required in future, but after some time. Okay, so replace page number 4 with page 5. Fine. Page 1, next string, next page required as page 1. It is there. Page 2 is available in memory, no page fault. Next page 3 is required. Page 3 is not available in this particular memory. Okay, so see the future strings. 4 and 5 are required. 5 must be blocked. Okay, and then 1, 2, out of this, which page has come first? Page number 1 has come first or page number 2? You can observe here in this, page number 1 has come first. Okay, so first in, first out. According to that, replace page number 1 with the required page. Okay, so page 3 is replaced by page 1, what is selected as victim page, because it is the page which has come first. Okay, so page 1 is replaced with page 3. Next, page 4 is required. It is a page fault. Page 4 is required. Observe the next pages. So it is page 5 is retained, blocked. Which has come first, 3 or 2? You can observe 2 has come here. Okay, hence page 2 is replaced by page 4. Okay, so this is for 3 frames, optimal page replacement. Similarly, for 4 frames, if there are 4 frames, you can see that number of page faults is 6. Usually, as I told, as the number of frames increases, the number of page faults decreases, because there is more space and I can store those values. Okay, so first 4, initial 4 pages are filled. Next, page 1 is required, no page fault, 1 is available. 2 is required, 2 is also available. 5 is required, it is a page fault. Observe the future strings. So next, 1 is required, block 1. 2 is required, block 2. 3 is required, block 3. Okay, so 4 is required next, but it is after some time. Okay, so first all these pages are required in the immediate future. Hence, page 4 is replaced by page 5. Page 1, 2, 3, next references, no page fault. Page 4 is a page fault. Okay, see the future strings. Page 5 is required. So retain page 5. Next, which has come first? Page 1 has come first. You can observe it has come here itself. Okay, so replace page 1 with page 4. Okay, and page 5 is required, that is there. Fine, this is optimal page replacement algorithm, but it